All right, welcome back. What I'd like to do in this video is kind of show you an example of a wiring diagram, which will wire this relay up for you, and then we'll convert that into a ladder logic diagram. And that'll give you a real good idea of how these things are developed, these ladder logic diagrams. Okay, so let's start with a power source over here. Let's say that we have a transformer coming in here, and this transformer, let's say, is 120 volts, and it steps it down to 24 volts. Okay, and one side of the transformer is the return, and the other side of the transformer goes to our relay. Okay, so we have a switch controlling a relay right now, step down transformer. This coil, of course, is rated at 24 volts. You could buy these at any voltage rating, AC, DC, so it's very imperative that you understand what your coil voltage is and also what your switching voltage is out here in that area out there. Okay, switching voltage on a general purpose relay, usually about 277 volts or maybe 240 volts DC. Okay, and then typically 24 volt DC relays are very common out there in industry manufacturing, but you can get them 120, you get them in all sizes. Okay, so right now we have relay action, but the contacts aren't doing anything. So if I closed this switch right here, okay, then the coil would energize and bring this armature down, okay, and send this away and take the normally closed contacts and make them normally open. Okay, so here you have a common, that's where we'll feed it, and then something will come out as a normally closed, and something will come out to be normally open, like so. Okay, so let's draw our ladder diagram here. Let's see, we could start here, I guess. And we have a switch, and we have our control relay over here. Okay. Now going across the top here, sometimes it's denoted what voltage is on the rails. Okay. These are the rungs and these are the rails. Okay, so sometimes they might put 24 volts here and then go across so that we denote that the voltage in this particular system is 24 volts in that particular ladder system. Okay, now let's go back over here. We're going to steal from the primary side of our switch. We're going to go feed our common. Okay, so if we were going to wire that here, we'd come off here, this power, right, unswitched, and then we'll go to some kind of contact that's here, and then we'll go to a light, and we'll come off another contact here, because we have the two contacts, right, one normally open, one normally closed, and we'll go to another light here. So let's say that then this first contact coming off, okay, is our normally closed, and that's going to go to a red light. So that's going to come on right away, which is good. But that means our system isn't working. Okay, at this point, so we know that the red light is on, and then we're going to come off of the normally open contact over here, and we'll go to a green light here. Okay, so let's come up here, and this normally closed is going to go to a red light, and we're going to take it back to our source, right, which is back here. This is our ground source right there. Okay, and we do that sometimes so we don't have to have a bunch of wires hanging all over the place. And then we're going to come off of our normally open contact, which is this one, and we're going to go to a green light. Okay, and we'll go to the same original source. Okay, so with my switch, my coil switch turned off, okay, and we follow the voltage up, we're going to follow our voltage. It goes through here. It's going to go all the way up, and right now it's going out the normally closed to our red light. So this red light will be on. As you can see right here, there's voltage going straight across. There's continuity there. Our green light is off. However, once we energize the relay by closing this switch, closing this switch here, these two will flip. Okay, the normally open becomes closed, and the normally closed becomes open. So in which case then the red light would go off, and we show that contacts are open by circling it, and then the green light would come on, like so. So what you have is a flip-flop first circuit, and this is a very common circuit out there when I could look down the line and see that the machinery and so forth is off because the red light is on. Okay, and once the green light is on, then I know that the system is running. I mean, this could go out to a motor or something, low voltage motor or something like that. Okay, so this is one way of doing things, and this is how relay logic or ladder logic is developed from. It would be cumbersome to draw this whole thing, in a ladder circuit like that. So we represent that with a coil like so. Okay, and you can see between the rungs. Let's lift this up a second. Between the rungs, it's not drawn there, but this is actually the secondary of your transformer. Okay, and this is the primary over here of your transformer, but that's typically not drawn. That's the 120, and then this is the 24 volts, and that's what this is here, but typically it's not drawn. It's just this information right here that lets you know that we're coming from a 24 volt source. Okay, and just to show you the advantages of relay, let's go down here a second. Okay, we'll draw another circuit. This time we're going to come up here. Let's grab our eraser. Okay, grab this eraser, and instead of coming off this, okay, I'm going to come off the 120 volt side. Okay, which is over here. Okay, and we're going to feed the common with 120 volts. So that's the beauty of a relay, that you have 24 volt control, which is nice and safe, and then you can have a higher voltage controlling your outputs and so forth. So we have to draw that a little differently. Okay, so you're actually going to have two. You're going to have one ladder diagram that brings on the coil. Okay, we'll call that CR, control relay. Okay, and then you're going to have another diagram that's controlling your outputs. Okay, and if you remember, this is normally open, going to a green light. Okay, and this would be the normally closed. I have them backwards here, but same difference, going to the red light. And then here you would see the rails of the ladder denoted as 120 volts going across. Okay, so it's just another beauty of relays, what they do. And they would have typically more than one set of contacts that are not associated with each other. So if you had another set of contacts that were down here, and this would be my common, and that would be the normally closed and normally open, I could put 240 volts, okay, on this common going into there, and I can come out the common and the motor, okay, normally open to a motor that's there. Okay, so now I'm bringing on two things at two different voltages, but my control voltage still remains at 24 volts, and it's relatively safe. Okay, so hopefully that gives you a good understanding of how to turn a wiring diagram into relay logic. And this is what electricians understand. And this, by the way, as we mentioned before, is what PLC programming goes by. It's called ladder logic programming and so forth. So it's kind of the same principle, because this is what electricians understand. And typically these are read, from left to right and from top to bottom, like so. All right, I hope this proved interesting for you. And if you didn't know much about how the relay diagram is turned into, wiring diagram is turned into relay logic, why, that's it. Okay, we'll see you on the next video.